Hey, young minds, future leaders and learners. I'm Anil Sir, your guide at Student Care Center. Get ready to embark on an exciting learning adventure with us. Our videos are packed with knowledge, fun, and everything in between. So sit back, relax, and let's dive into the world of education together. Let's get started.
Ever wondered how a football soars through the air after a kick or why a book stays put on a table unless someone moves it? Welcome to the fascinating world of force and laws of motion. The universe we live in is governed by certain principles, and one of the most fundamental is the concept of force. It's the hidden hand that pushes and pulls everything around us. But forces aren't all alike. Some are balanced, keeping things in place or in a constant motion, while others are unbalanced, causing changes in speed or direction. Together they create the rhythm of our daily lives. But that's not all. There are also laws of motion, rules that explain how forces work and interact. In this video, we'll break down these laws and delve into the concepts of inertia, mass, and the conservation of mass. Now, with that basic understanding, brace yourselves as we dive deeper into the laws of motion. Imagine trying to move a heavy box. It resists your push, right? That's inertia in action. So what exactly is inertia? It's the inherent property of an object to resist any change in its state of motion. It's like when you're cozied up on your couch on a lazy Sunday and you just don't feel like moving. That's you experiencing inertia. Now, what's the connection between inertia and mass? Think of mass as the measure of an object's inertia. The larger the mass, the greater is the inertia. So a freight train has a lot more inertia than a bicycle because it has a lot more mass. That's why it's much harder to get a freight train moving than it is to pedal a bike. With that, we've grasped the concept of inertia and its relationship with mass. Up next, we delve into the conservation of mass and its formulae. What if we told you that you can't create or destroy matter, only change its form? Intrigued? Let's explore the law of conservation of mass. This fundamental principle of physics states that the total mass of an isolated system remains constant, regardless of the transformations happening within it. In other words, matter can't be pulled out of thin air or vanish into nothingness. It just changes its form. Now let's get a bit mathematical. The formula for conservation of mass is pretty straightforward. It's simply m equals to mf. M stands for initial mass and f stands for final mass. This means the total mass before a change equals the total mass after the change. Consider a burning candle, for instance. The wax and wick transform into heat, light, soot, and gases. But if you could capture and weigh all these products, they would equal the original mass of the candle and air consumed. And that's a wrap on the law of conservation of mass and its formulae. But don't go away just yet. We've got a quick recap coming up. It's been quite a journey, hasn't it? Let's take a moment to go over what we've learned. We started with the concept of force, discovering it as a push or a pull that can set objects in motion or change their direction. We then delved into types of force, namely balanced and unbalanced, and how they shape the world around us. Next, we explored the laws of motion, the fundamental principles that dictate how objects move. We also got to grips with inertia, that inherent property of objects to resist changes in their state of motion, and how it's directly proportional to mass. Finally, we wrapped up with the law of conservation of mass, a fundamental principle of physics that states mass cannot be created or destroyed, only transformed, and its corresponding formulae. Remember, mastering these concepts takes practice. So keep exploring, keep questioning, and if you need more help, don't hesitate to call Anil Sir at the Students Care Center at 9999060986. Until next time, stay curious.